Hello everyone, welcome to another Novedge webinar. Today, manage massive point cloud data with VisionLiDAR. Compared to other software solutions, VisionLiDAR is faster and compresses the data better during preparation and loading. VisionLiDAR lets you work, in fact, with over 25 billion points and is designed to simplify and automate work for LiDAR point cloud processing in the air, on the ground, and in motions. Today's presenter, Anthony Belisle, is a geomatics consultant at Geo-Plus Inc. He has more than 4 years experience in LiDAR, data acquisition and calibration, as well as many years of GIS field surveying and mapping experience. He holds a Bachelor of Geomatics Applied to the Environment, and he obtained from the University of Sherbrooke in 2011. Before we get going, here's an overview of what we do at Novedge. Novedge is one of the largest online stores for design software. We offer a huge assortment of software solutions that cater to virtually every designer's needs. So come visit us at novedge.com. And for more daily software news and limited time promotions, you can check out the Novedge blog and follow us on Facebook, Google+, and Twitter. Coming up next week, crash course on RealFlow 10's new features. Last but not least, today's webinar is free and is being recorded live. And if you want to rewatch this or any webinar episode in our collection, just head on over to Novedge's YouTube and Vimeo channels. And now I'm going to share Anthony's screen and make you the presenter so you can start showing off this fantastic software.
Perfect.
There you are. Take it away.
All right. So, hello everyone. So, as Barbara said a bit earlier, I'm Anthony Belisle. I've been working with LiDAR data, and I was working with LiDAR acquisition for a number of years. Actually, I worked in airborne surveying for a number of years, and I came to Geo-Plus to work on their LiDAR processing software, which is VisionLiDAR. So basically, just to give a little introduction to Geo-Plus, we've been creating software for surveyors and civil engineers for almost 30 years now. And we've been developing VisionLiDAR for perhaps, let's say 5 years, and it's been on the market for maybe 2 or 3 years. So, and we're constantly working on improving the software. We're always adding new functionalities. Actually, the version I'm showing you, actually there's been new development since. We're in the process of testing it. So we're always coming out with new and exciting features to show you guys. So like we heard in the introduction, VisionLiDAR can manage literally billions of points, which can be really great because in comparable software you can't even see sometimes over 1 million points in some certain CADs, for instance. So VisionLiDAR allows you to create very, very large projects with a huge amount of points. So first of all, to start out, if you want to create a new project, simple as that, you just enter in a name and you give a project location and you set your source file. So your source file can be anything from a terrestrial, a mobile, or an aerial survey. And it can be any number of LAS or LAZ. Also, the compressed format is accepted, or E57, PTS, and also XYZ for that matter, CSV, and X3A type of files. So in here, for instance, I have a number of files here. I can select any number of files to import into my project. That way, if you have, like I was saying, if you have different sources of data, like aerial and mobile, for instance, you can import both of those into the same project and view your data together. Here we have a few settings for the tiling. And as I'm going to show you when I open up this project here, the tiling is used. Basically, what we do at the beginning is the software is telling VisionLiDAR, okay, I want to put all my data, I want to tile it into tiles that are, in this case, 5,000 points per tile. This number makes it so as you move along here, every tile is composed of, for instance, 5,000 points. This way you can visualize very rapidly all of your LiDAR points. And as you see, as I move along, as I get closer and closer, the definition is getting better. This way you can easily create projects with a huge number of points. So in this case, I'm just looking at this file here. It's just one drone scan, for instance, of a wooded area, and there's 521 million points. And all this is being viewed on a small laptop, like it's just a laptop we got from Costco. And I can visualize all this data very fluidly and very quickly. So that's one of the interesting things about VisionLiDAR. So furthermore, I'm going to show perhaps this project here, just to show a couple of other features that we've designed with VisionLiDAR. So again, here you can see still the tiles being loaded as we move along. We've created a really easy way to navigate through your data as well. So everything can be, all the movements can be done with a simple mouse click or a mouse pointer or is it the roller? So here you can see, for instance, if I double click on a point, I have my axis of rotation around this point, and if I double click here, the axis of rotation will have changed. So that's really, compared to other software that I've used, it's really more intuitive and really easier to navigate than certain other programs. Up here we have a couple of icons in case you want to navigate easily. We have the top view or left view, just as any other CAD, so the front view. However, you should have noted by now, VisionLiDAR is a standalone software, so you don't actually need, but you can export, for instance, any points that you vectorize. You can export them to DXF format, but you don't specifically need a CAD or a GIS to actually use VisionLiDAR. Maybe another interesting tool we've developed here is what is it, the edge locator. So what it does here is it will find difference in between two planes. It's going to highlight the edge here. So in certain cases where you have difficulty seeing your data, or for instance, you might have data that has no RGB information or no intensity information, you can still see through this because the software is actually analyzing the surface. So if I was to, for instance, pick some points along my edge here, you can see here, you can see the result in real time. It's actually picking points through your edge locator. So that's one of the tools that we've developed for the visualization of your data. Now here we can see this was a terrestrial scan that was done. So we have a few points of scan here that we can see. And how this was done, it took a scan and then took some photos. So the RGB photos were merged into the LiDAR scan. So we're viewing the color by RGB, but we can also view the scan by intensity. So here we see, which is a more adequate representation of objects often, because the RGB can sometimes have some, like the RGB, like actually the color on the LiDAR is sometimes prone to errors, but intensity is really the actual point, the actual reflectiveness that was measured on the LiDAR point. So here we see with intensity view, we can color by class if we've classified our points beforehand. So in this case, I've already classified a number of points. So we can see here in my classes toolbar here, we have a number of classes that can be turned on or off accordingly. We can also view by normals if I've calculated my normals. Now this is not a great example, but I'm just going to switch to this project here, where you can see this is what normals does. It's in case, like here, I have no RGB information or no intensity information. If I want to view my, if I wanted to view my data adequately, I would calculate my normals, and the software finds all the horizontal planes and all the vertical planes, and will color them a different color. So it can help you for the visualization of your data. Color by scan is in case we have two or more different scan files. So in this case, we can see here we have two separate files, which you can hide or show as you please. Color by elevation, simply coloring according to the elevation of your data. You can see an example here. And finally, there's a color by distance tool which we've been developing. Actually, what this tool does is we have a plane detector where it's going to look for planar surfaces, and within that given planar surface, say I'll just choose a surface here. So I'm just going to pick a plane here. So according to the plane shown, see, we've detected this plane here, for instance, and we have all the data is being colored accordingly. So all according to the distance from the plane. So if it's above, it's going to be in blue, and below it will be in red. We've really been working on, this is kind of more of a beta version, but we've developed a tool where it detects a building front, for instance, and you can analyze a building facade according to a given plane. And we've also developed a PDF export, so you can actually see the result in PDF format. So you can see like the differences, and like for instance in this case, I don't know, the turquoise would mean that it's 7 centimeters or 7 inches away from the central plane. So you can actually measure deformities in your surface this way. So that's another visualization tool that we have. Maybe moving along to my classification. So one thing that's really interesting with VisionLiDAR is that we have some automatic classification tools available to us. So we have a number of classes. For instance, in my Explorer here, I have up to 128 classes of LiDAR data that are available to me. However, I have 4 here that I can classify automatically. So the ground class here, as I can see, is class number 2. I can classify these points automatically by using my ground classification. So this tool is going to take a it's going to take a few parameters, and it's going to be searching for the lowest points in my point cloud. So in this case, I have 20 degrees of slope tolerance. Anything over that will not be considered. And given cell size, so the cell size is the radius with which the software is going to search. So the smaller this value is, the smaller your triangulation will be. If you wish to create a constrained area, you can do so by limiting by radius, but you don't have to. And here is the classification. So you're actually telling the software, okay, I'm going to send towards the class number 2, because that's the standard ground class according to the standard. And here you can create a surface as well. So once you run the classification, you will create a surface. So I've already done a number of these classifications here. So for instance, we can see this one here is this is the surface that I was talking to you about. You can see here this is the triangulation that was created already, and it's following the ground as well. So that's what it looks like, and that way all the points detected will be sent to class number 2. So we can see here the result of my classification looks something like this. Furthermore, we have also a classification of buildings. So in this case, it's working similarly to the ground classification. However, we are looking for vertical surfaces in this case. So again, a slope tolerance, but this time against a vertical surface. And the cell size again is going to be the precision of the detection. So we can see here all the points detected will be sent to class number 6. Moving along, there's the vegetation detection, which like a little different from the other two. In this case, it's going to be searching for cells with a high degree of variability. So with a certain degree of variation, again, a given cell size, which will be the precision of the detection, is going to send all the detected elements to class number 3. So we see here a few bits of vegetation that were detected. And finally, we have a noise detection, which is going to actually detect isolated points in my point cloud. It's going to send them to the noise class, which is the low point or class number 7. So this tool will help isolate, find and isolate, for example, atmospheric noise, or like any erroneous points in your point cloud that you may have. However, you may have noticed that there are more than 4 classes here, and I've classified more than into more than 4 different classes. So you can see here there are a few other information that have been classified. So if I was to look at, there is a way to classify data manually as well, and it's fairly simple to do. So I'm going to simply turn off my ground class because I don't want to reclassify some ground points. All I have to do is simply create a selection around my object that I want to classify, and I create a selection, and once I close my selection box, I get a window telling me I've selected a certain number of points, and here are 7,000 points. I'm going to reclassify these to class number 13. So the software is going to send all detected points within my given area and is going to classify them to the vehicle class, as you can see here. Another interesting tool that we have with VisionLiDAR is you can create a selection around a certain object, and you can tell the software to create an extraction for you. So here, what I did was create a selection around this object. Again, it's telling me there's a certain number of points in your selected area. But this time, instead of classifying directly, I want to extract. So the software is going to bring my selected points here. So we can see more of an extracted view. This can be useful for if you have a lot of information that you want to reclassify, for instance. And what can be done here, once you're in your extracted view, you can change anything. So here I noticed that there was a little extra information that I might want to remove. So I could do so by creating another selection within my main window, and I could reclassify to, in this case, not classified. So it's going to remove that data from here, and then once I return, I can bring my extraction back, and it's going to have applied those changes to my main drawing. So that can be done as well. Know that we're in the process of eventually developing a way to, detect certain objects more automatically. It's called by machine learning. You could have an enormous point cloud and tell the software, okay, all objects that look something like this are vehicles, and the software is going to detect all those features and is going to send them to the vehicle class. However, that's still in the works, but eventually that would be something that would be really interesting, where the users don't actually have to classify the features themselves. They'll be classified kind of semi-automatically. So I've shown you the Classes tab here and the Scan tab. And there's also an Object tab. So the Object tab can be really useful if you've detected your ground, for instance. Like I showed you a bit earlier, we have a surface detection here. We also have planes, if we've detected any planes. So you can see here for that color by distance tool, I've detected a couple of planes here. Any cylinders you may have detected. I'll show you a bit later how to detect the cylinders. And also trees, in case you have any, but in this case we don't really have any trees. But here you can manage all of your objects, so that's another interesting feature. It's also to note that any class here can be modified, and you can also change the color if you feel the need to do so. You can always, everything is pretty customizable here, so you could change the look of your data as well. So moving along, I'm going to change my drawing here. So here is a scan that has been done with a mobile scanner. So normally a LiDAR scanner mounted on a car or a truck. So here we can see a number of features that may be interesting to vectorize. It's a very, it's kind of a cityscape, and there's what we notice here as well is there's painted lines that are pretty easy to identify. So I'm looking at my data in intensity view. So if I introduce you to some features that we have here, we can connect any VisionLiDAR project to a database. So the database is a Microsoft Access or an SQLite database, where you can connect your database, and you can connect a configuration. In this case, it's the Ministry of Transportation here in Quebec. So if I was to show you a few of the points I vectorized here, it looks something like this. So here what we have are a number of chains with all these lines are actually called chainings because they're points connected together through a common feature, right? So for instance, here's the center of the road, or here is simply a point. For instance, it could be an electrical post or something. So all this information, you can vectorize information manually if you wish, obviously. So here I have some information on my database. So I have a number of points that I've already detected. So I have in my database, you can see here I have the number, the ID, the XYZ, and the P code. And so here you can see what I was talking to you about with the P, like the configuration. You can see actually the P code here is actually giving out the nature of your point. So if you have a center line, you could put the P code for the center line or the P code for a building, and you would have that appear. So these are different features that are in your database here. Also, it's to note that at any time you can export your data to a DXF, so all these lines, these polylines, and these points will be exported. So as I said a bit earlier, you can vectorize information by simply picking points in your drawing here. Like if I created with a line here, you would have a line number. However, this would take a lot of time. It would take a lot of time if you had to vectorize all your information manually. It would probably take you a couple of hours to do all that you just saw here. However, we've developed a couple of features to make your work easier for you. So for instance here, we can see there's a portion that I haven't done yet. So using one of our tools, we have a tool that can detect lines by intensity. So with certain parameters, so here we're looking at difference in intensity. So that you have to see the difference in intensity. That's important. And within a given direction tolerance, we're going to be detecting some lines here. So I simply pick 2 points with a similar intensity, and the software is going to add a point every 5 feet, for instance. This is the segment length I'm giving. So here, just with as I click start, the software is going to detect points along my painted line automatically. It's going to add them to my database automatically. So I don't have to actually pick all the points myself. The software can actually identify and vectorize these points automatically. So that's one of the examples. We found another feature that was pretty interesting here. Actually, I forgot to show it here. We can use this tool also to vectorize power lines. So if I was to look at the feature here as well, I also use this tool to detect power lines here. So as long as the power line has the same intensity the whole way along, it's going to work just as well. So here in this case, we have the points are much closer together. Moving back to this drawing here. So as I showed you, like there's a whole number of points that have been vectorized with this this project. Just so you can, just to give you an idea of what it looks like with your CAD, you could be using actually any CAD that supports DXF format or CSV format can be used. So here we can see I've imported my my points and my lines. I've imported them to my CAD. In this case, it's BricsCAD, but it could also be MicroStation or AutoCAD, for instance. So we can see here all the points, so the ID and the elevation are inscribed here, as well as the P code. So if you, for instance, if you have the, we have other tools that we've developed with Geo-Plus. We also have a couple other tools where when you import your vectorized information, you can have all the elements will be sent to the correct layers. So here you can see they're on different layers actually, according to the given P code, which is something else that could be really useful for surveyors in particular. So here you can see as well the features that were detected were also detected in 3D, because we can see here the curve of the road, for instance, or simply the height of the buildings. So that's gives you a view of what a more advanced vectorization of LiDAR data looks like. Something else that we've developed with VisionLiDAR, which could be actually quite useful for certain people, you can create an alignment. So, for instance, it could be simply the center of the road would be your alignment. So if I look at this here, I have a curve going along my road, and I have a section tool, so I can actually create a cut through my road. So along my given alignment, you can kind of see it in white here. So with a given thickness and height and width, I'm going to create a secondary window here where I can see the section view of my road. So I'm just going to move this element here. So as I move along here, you can see the features being updated in my secondary window here. So certain users have been using this to vectorize their road. Like here, you can kind of see the sidewalk very well. So you can actually vectorize the sidewalk as well. People have been using it this way to actually move along their alignment and actually vectorizing in a, let's say if I was to add another one. So I could just simply show my window here and say I pick one point here and pick one point here, and I move along, pick another point, and then pick another point. Say I move along here, and they've been doing it this way. So it kind of it works well. However, it's quite a tedious way of working. If I was to show you here, you can see I have some chainings that are being created along here. Actually, I have a disruption here, so I would probably have to change that. But you get the idea, where as I move along my sections, I'm actually creating a chain as I move along, and I'm picking points. However, it was taking a lot of time this way, so we developed another tool where we can actually vectorize in a more automatic fashion. So again, here we have an alignment. Still works with the given alignment, so I'm just going to show my alignment up here, so I can kind of see it. Actually, if I turn off my layers here, you can see my alignment is showing up here. So if I open up my other tool, so it's called the road bisections, and this was really asked for users that often have to vectorize information along a road. So in this case, if I look at my tool here, I have a dimension of my sections a little similar to earlier. My alignment has been selected here, so I have a start and an end to my alignment. So it goes for 350 meters, or feet in this case. And here you can see on the left the sections. So at different stations along the way, so in this case every 5 or 10 feet, I've created a station where you can actually see this section view of my window. So it looks something like this, where you have a section view. However, in this case, I have created a template. So my template looks something like this. So as I move along on my sections, the template is being reapplied according to the last used station. So the way this works is you're gonna check to see if the template is following adequately your surface. Is it representing your surface correctly? And you can add or remove, or you can have as many or as little points to be as precise or as unprecise as you wish to be. If you wish to move certain points, you can do so easily. So in this case, I can move 1 point to adequately represent the surface. You can also move 2 points at a time, or you can also move the entire template. So you can see something like this. I just want to be sure. Here I have to move this back here. And once you're satisfied with the placement of your template, you can apply it to your station, and then you would move along, right? So as you move along, the software is connecting each point together, and it's going to create a chain along every connecting point. So in the end, you have a template that looks like this, and you have a number of stations, and when they're all filled out, then you can draw your chains here. So in the end, it looks something like this, where at every given section, I've actually connected all the points together. And here we're actually getting information about the edge of the road, for instance, and we're also getting the side of the ramp here. And even here, as there's an underpass, we can see the terrain lowering. So this is also all features that have been vectorized. And we can see here if there's an area that needs more detail, you can create more sections than you have. For instance, if you've added the interval every 10 feet, you can insert new stations as you wish. So the end result in a CAD would look something like, I'm just going to open up my example here. Actually, I think I don't have it, but I'm going to bring it into my drawing. Okay, so it looks something like this, where you can use, for instance, on a surface like this, you can use a loft function. I know this is a function with AutoCAD, where you can actually create a given surface. So this is really a representation of your LiDAR data that you can really bring into your CAD quite easily. Because here there's only a number of points, right? You don't actually need, that's one of the disadvantages of LiDAR, is it creates too much information, right? So by using this, you're generalizing your information, but you're actually bringing out the most important features. So here we can see certain details that we wanted to see that we can see really well here. So that's one of the features that can be used as well. We have a similar example here where we had to vectorize a tunnel. So this was done as well. I think we have it for this one as well here. Yeah, so this feature was done as well here. So I think I displaced a feature, but still you get the idea where this is a tunnel that can actually be vectorized as well and sent to, again, you can always export to DXF to import into your CAD as quickly as you need to. So maybe moving along here, for those of you who would want to do any type of volume calculations, or simply analyze any surfaces that you may have, we have a number of measurement tools with our software. So, for example, if you simply need to measure a distance, you can do so here. The software is going to measure the distance in 2D and also in 3D. We'll measure the slope between the 2 points that you've picked, and also delta Z, which is the difference in elevation. We also have another tool for angle measurement. So any measurement here that's been done also will give you an angle in 2D and 3D. But moving along here, we can see that there's, for instance, a stockpile. So by detecting my ground, as we saw a bit earlier where I detected my ground, I can send that information that I've detected. So I've detected a surface here. I can send that to my civil module here, which is included with VisionLiDAR. So here I'm loading my surface. If you look at actually what the data is here, it's actually much more points than, in this case we're talking about 120,000 points. But we've narrowed it down, right? We've created a triangulation of my surface. So here, this is what my surface looks like when it's triangulated, colored by elevation. We can also create contour lines from my stockpile here. If we need to do so, you can add annotation if you wish to do so. All these contour lines can be sent to the CAD as well. We can export to DXF. Or also, you can always export these features to LandXML as well, for if you use Civil 3D, for example. So those are the contour lines. And there are many different ways of creating your contour lines. So according to your preferences, you can create your contour lines by polyline, which will give a kind of a more rectangular way. But I find smoothing is the best looking one, where it smooths out the differences between the elevation. If you need to create a grid around your surface, you can create a grid. This grid is going to vary according to the height, so it can be something else interesting that can be done. And finally here we have our volume calculation, where you can calculate your volume according to an existing surface. So in this case what I did is I'm comparing my surface, here the triangulated stockpile, to its contour. So I'm actually just want to calculate the volume of my stockpile. But you can also compare two surfaces together. Actually, if you have two surfaces that have a difference between them, you can even create a surface between those two surfaces. And also, you can calculate according to a given Z level as well. So there are different calculation methods. So by triangulation or by grid. And these are a couple of those features that I was telling you about, where you can save resulting surfaces between them, or you can make differential contours as well. And you can also simply calculate the surface, the volume, sorry, within a given fence as well. So you can pick on the screen. And in the end, you get a volume calculation report here. In this case, it's in French, so you might not understand it, but it's simply because Our software runs in English and French, and I probably ran the volume detection when it was in French, but still you get the idea. Here there's the area in 2D and the area in 3D, and you get the cut and fill values for the volume as well. So, and you can also change your swell, what is it, the swell factor. If you have depending on the type of soil you have, you can also change this factor as well. And this whole report can be saved in a text format. Maybe showing you a bit of a bigger type of project. So even going back to our very large project that was collected by drone here, I'm just going to show you this. So I have my triangulation that was done on this surface as well. So I've detected my ground and triangulated my surface. So it looks something like this. And with my civil tool, again, I can look at my surface and draw it out here. So I've created an outline of my surface, and I'm going to triangulate it. So it looks something like this with the color by elevation. I can also create my contour lines really quickly. So something like that. And also the volume calculations that I said before. In this case, the calculation was done in English. So, and in this case, I've calculated according to a given Z level. Now, I was talking to you about alignments a bit earlier. So I've created another alignment here, which is the road that goes here through my my forested area. So with my profile view, I can actually view my surface. If I look here, this is the profile view of my surface. So we can see with a report which can be exported my alignment and my surface. Maybe looking a bit further, we can see here a section view as well, where moving along my given alignment at different distances along my alignment, here we can see the section view being updated, and this is as moving along my alignment. So you can see their section view at different channels. So that's something else that can be useful. If I was to look just quickly here at the ground detection, right? Just to show you how accurate the ground detection is, we can see here a number of trees, but they're not actually included in the ground detection because the software is only using the lowest points in my ground. So here we're following the terrain. So that's how accurate the ground detection is. Maybe if I was to show you another example of that, I could show you this mine site where we've detected the ground on this surface as well. So you can see here the ground was detected even on a 90-degree slope, so which can be also really interesting. So even here we can see features like the buildings or vehicles were not included in the ground classification or detection. Maybe there's a few other features of automatic detection that I haven't shown you yet. So in this drawing here we can see, well, first of all, I've detected already a number of cylinders, but how did I do that? I simply attached my database, and I can use my cylindrical detection tool here to detect cylindrical features. So any cylindrical object I may have in my drawing, in my project, I simply have to click on the feature, and the software is going to detect these features for me. So it can be any type of cylindrical object. Like here you can see a lamppost, but it could be like a fire hydrant or a tree trunk or something. And what the software does is creating a cylindrical object, but it's also placing a point at the base of my cylinder. So, and what we're doing is we're also storing here the radius information for the cylinder. So even something as variable as a tree trunk can be also detected with this tool. Yeah. So all these features can be exported to DXF if you need to. So here also we've developed another tool in case you have a good enough resolution with your LiDAR data. So we have a tool here where you can detect your edges. So a bit similar to the line by intensity tool that I showed you a bit earlier. You can pick 2 points along the edge of a sidewalk and begin the detection, and the software is going to detect the sidewalk for you automatically. So what we have here is 2 lines. So we can see here two given lines, line 128 and 129, that have been detected automatically. In case I'm ever unhappy with a point that was detected, like, I don't know, for instance, I find this point is a bit too low, you can always correct a point manually by using the pick coordinates here, so I can simply move it there, for instance. Another feature that was really interesting when we did the cylindrical detection tool, we had a few cities approach us, notably the city of Montreal, who has a mobile scan of the city, and they wanted to be able to vectorize the information for their trees. So here I'm just going to show you a mobile scan where we have a number of trees included with them. So here, following a similar principle to the cylindrical detection, the software is going to be able to detect trees as well. So if I was to open up here, for instance, if I give the software, I can tell them here, I'm going to add a tree. So the software tells me to pick a point on its center, and the software is going to detect the tree for me automatically. So a number of features are going to be added to the database automatically. So the center point of my tree trunk at the base. So here you can see the XYZ coordinates. The tree height, which is the top of the tree. The trunk height, which is the measurement at the top, at the beginning of the first large branch. DBH, which is diameter at breast height. These are all regular measurements done in dendrometry, which is the science of measuring trees. And the crown diameter, which is the diameter of the foliage here that we can see. So all this can be detected automatically. If I wish to do so, also I can change these values manually. But if I feel confident with what VisionLiDAR has collected for me, I can just leave it at that. Also, if you determine it was a different type of tree, you can put it into a conical format or a spherical representation. So in the end, what you do when you've inventoried all the trees in your area that you wish to inventory, I'm just going to show what the report looks like in the end. So it looks something like this, where you have all the names of the trees, and you have a center coordinate, and the height, trunk height, and diameters that show up in the report. We've been working on a new tool where you can give a fence within your project, and you can have the software detect all the trees within a given fence. So that can greatly reduce the time spent actually inventorying trees. Something else I like to show normally with this type of data is here we can see something that's quite interesting. So here I have my data which was collected by mobile with a mobile scanner. But with VisionLiDAR, actually what's quite interesting here is I've been able to combine this information with the aerial survey. So here we can see I have two aerial tiles that have been collected as well. So I know more and more because aerial surveying is so hard to acquire, it's very expensive, and mostly it's on the government or you know, municipal or state level. I know more and more states are offering free or virtually free LiDAR data. So what can be interesting with this is you'll be able to integrate the aerial data, which is most of the time is kind of low density. Like if we look at this information here, we're talking about 10 points per square meter, which is really good. But in terms of if you want to actually vectorize things like trees or painted lines or something like that, it's really better to be in terrestrial, like a ground-based survey, like a mobile or terrestrial scan. But you can actually combine these two information here. So we see here we have a more detailed view of our project area. So it looks something like this. And also here, just to show you again, you can have your classified data here, where all the buildings have been classified. So you can always segment this information out if you wish to do so. It looks something like this. So that was pretty much it for me. That was most of the features that VisionLiDAR has to offer.
Thank you so much, Anthony. That was really a great overview. And I loved all the great features, and I'm sure all the land surveyors and civil engineers did appreciate them too. I'm just leaving a few seconds to see if anybody would like to ask some questions. You can type them in our question box in your control panel. And in the meantime, while we're waiting for questions, if you have any, I'm taking the screen back. So you should be able to see my screen. And yeah, so Anthony's here, and he can, any questions, or, if you can think of any question now, but you have questions later, you can always call Novedge and let us know.
We're always available for any questions, or if you want to have try out a session, you just contact Edmund from our sales team. Barbara will have all that information probably.
Of course. Yes, okay, that's pretty much it then. I would like to thank you everyone for joining us today, and I want to remind everyone to visit our page at novedge.com, where you can find VisionLiDAR and all the other CAD that can go with it. Novedge is the best way to buy design software, and also, we have a lot of software for design. And if you wanted to find out all the latest specials and new releases, you can look us up on Facebook, Google+, or Twitter, where we can post. We always post all our latest specials and promotions. And I want to remind everybody that next webinar will be on RealFlow 10's new features. And to watch today's webinar or previous ones, check out our Novedge YouTube and Vimeo channels. Our webinar playlist has webinars for every software taste. Thank you so much for the fantastic presentation, Anthony, and thank you everybody for joining us today. Have a great day. Bye-bye.
Thank you.